In this video, we will learn about Yamazen's evaporative light scattering detector, the ELSD 100X, a compact and versatile detector capable of being added to any Yamazen SmartFlash system. The ELSD 100X is a universal detector, allowing for the fractionation and collection of any compounds by peak mode, with or without UV absorption. This detector is a strong tool for chemists because it can detect a wide range of samples, from trace components to large-scale samples. The ELSD 100X is easy to use and does not require any special operations. Just turn it on and it'll start working with your flash system. Your SmartFlash system will detect both ELS and UV simultaneously for optimal peak mode separation. Detected peaks must match between both ELS and UV. Yamazen's split technology synchronizes the timing of both the ELS and UV chromatograms. As the detection timing gets matched, the peaks get matched and are attributed to the corresponding fraction. Elution begins when either the UV or ELS peak exceeds a determined threshold. ELS detection is prioritized in this process. You can set the threshold for both UV and ELS to separate your sample by peak mode. Accurate sample purification is achieved by Yamazen's unique flow path configuration. As you can see in the example, the ELS and UV chromatograms both capture the sample in fraction tube number 3. ELS chromatography is an easy and powerful method for chemists to target and separate samples that do not absorb UV light. By using a coloring agent during TLC, the method can be set automatically based on the color of the TLC. Even UV transparent samples can be efficiently separated using this method. You can see in this example that the elution position of the sample is controlled despite it being UV transparent. Yamazen's ELSD also has excellent baseline stability. Our temperature control and spray technology eliminate the influence of the solvent, so even if the elution solvent is UV absorbent, the ELS baseline is not affected, and the peak can be clearly discerned. Temperature settings are different between normal and reverse phase, so Yamazen has made it easy to switch between the two by just pressing a button. A very small amount of flow from the column is split to the UV and the ELS detectors. This flow is accurately controlled to ensure that there is no deviation from the fraction, while still getting excellent detection. Next, we'll learn about the peak threshold when the ELSD 100X is being used. The fractionation range for UV and ELS can be set separately. By default, they both have a fractionation range of 0.16 by 5%. When the ELSD range is changed, the threshold also changes. In this case, since the UV threshold is lower, UV acts as the trigger for fractionation. If you instead want the ELS threshold to be the trigger for fractionation, you just have to increase the sensitivity of the ELS fractionation range. In this case, if the ELS range is set to 0.04, fractionation will trigger at the same time as UV. In the same way, the UV fractionation range can also be changed to a higher sensitivity. However, increasing the UV detector's sensitivity allows it to pick up solvent absorption, even with standard solvents like hexane or ethyl acetate. As a result, we recommend leaving the UV detector in the 0.16 range and to use the ELSD as the more sensitive preparative trigger. Since Yamazen's ELSD has a high baseline stability, it's possible to separate trace components with high sensitivity, while avoiding wasting test tubes due to noise. We recommend using the ELSD 100X to not only separate samples without UV absorption, but also to perform reliable purification with high sensitivity detection. Thank you.